Okay, continuing on in R.8, let's talk about simplifying. So you'll be asked to simplify a given expression, and what you're given here will depend a little bit from one to another, but you might be asked to FOIL. So this kind of combines the adding, subtracting, and the multiplying. So you might be given something like the square root of x plus 2 times the square root of x minus 1. So now I need to FOIL, and I think when you're doing something like this, the best thing to do is to just take it one step at a time. Try not to do too much in your head. So first, I will multiply the square root of x times the square root of x. Outside, I have negative 1 times the square root of x. Inside, I have 2 times the square root of x. And then last, I have negative 2 times 1. Okay, so square root of x times square root of x is, remember, this is just the square root of x times x, or x squared. So then this is minus square root x plus 2 square root x minus 2. The square root of x times x, or the square root of x squared, is just x. Now these I can combine because they're like terms. So negative root x plus 2 root x is just plus root x, and then minus 2. Now I'm down to 3 terms that I can't combine, so I can leave it just like this. Okay, so when you're given something like this, I would take your time, just show all your work, and just take it one step at a time. All right, now let's talk about rationalizing the denominator. So when you're simplifying a radical expression, it's not considered to be simplified if you have a square root in the denominator. So let's talk about how you can eliminate that. So you'll be asked to rationalize the denominator. Okay, so, and with this, we're just going to deal with square roots. So this is if you have something like the square root, or 1 over the square root of 3. All right, this isn't considered to be simplified because there's a square root in the denominator. So to get rid of it, I'm going to build a perfect square in the denominator. So when I apply the square root, I just get a regular number. So I'm going to multiply top and bottom by the square root in the denominator. So square root of 3 over square root of 3, because I'm really not changing the value, I'm just multiplying by 1. So now multiplying across, 1 times the square root of 3 is square root of 3. Square root of 3 times square root of 3 is just 3, because this would be the square root of 3 times 3, or 9, which is 3. Isn't that prettier? So we changed 1 over root 3, because it wasn't considered simplified, to root 3 over 3. All right, one place it can be somewhat confusing is if you have something like 2 root 3 on the bottom. So now what do I multiply top and bottom by to eliminate the root 3 in the bottom? Again, you just have to multiply top and bottom by the square root in this case. You don't have to multiply it by 2 root 3. Again, you can. You'll just have a little bit more simplifying to do at the end. But really, you just need to multiply by root 3 over root 3. So now, let's see, what do I have in the top? Remember, these are both square roots, so this is just the negative square root of 2 times 3, or 6. And then on the bottom, I have 2 times root 3 times root 3. Remember, that's the square root of 9, which is just 3. So this is the square root of negative square root of 6 over 2 times 3, or 6. Okay, can't simplify here, can't cancel the 6's because this is actually the square root of 6, not 6. So there's no common factors there. So that is simplified. Now, the next thing you can run into with this would be something like 2 over, if you have a sum or difference in the denominator, that makes a difference. Because notice the two that we just looked at, the first one we just had a single root in the denominator, and with the second one we had a product, we had a multiplication. Now, just like we've said with everything else, addition and subtraction is a little bit more complicated. So what I need to do here to get rid of the root in the bottom, it's not going to be enough to just multiply top and bottom by root x. That would get distributed by this, and it would actually then create more radical terms. So what I have to do is I have to multiply both top and bottom by what we call the conjugate. The conjugate is just the opposite. Really what we're doing is we're building the difference of perfect squares. So the conjugate of 3 minus root x is 3 plus root x. It's just changing the middle sign. If it's subtraction, it's changed to addition. Had it been addition, like let's say we had 1 plus root 2, the conjugate would be 1 minus root 2. So it's just that middle sign that changes. So for example, if I had negative 2 plus root y, the conjugate would be negative 2 minus root y. So back to the problem, I'm going to multiply top and bottom by the conjugate, 3 plus root x over 3 plus root x. So now when I go to multiply, we need to remember that these are just understood to be in parentheses, so I actually have to FOIL, and up here I have to distribute. So the numerator becomes 2 times 3 or 6 plus 2 root x, and the denominator, here we're going to FOIL. 3 times 3 is 9. Outside is 3 times root x, so that's plus 3 root x. Inside is minus 3 root x. And then last is negative x times, negative root x, times positive root x. So a negative times a positive is negative, and then that would be square root of x times x, or x squared. So we have 6 plus 2 root x, and then on the bottom, those two make 0. So I have 9 minus the square root of x squared is just x. Okay, so can I cancel between the 6 and the 9? No. Remember, just like with any other rational expression, I have to factor before I can cancel. So, can I take anything out of the numerator? Yeah, actually you can. You can take out a 2, and that would leave me with 3 plus root x. However, there's no GCF in the denominator, and so nothing will simplify. So really, your final answer could be either this, or had you taken the GCF out of the top, we could have this. So either or is perfectly fine. All right, so how about a you try for rationalizing the denominator? So you try, how about 3 over x minus the square root of 2. And see what you come up with, and we'll take a look at that in class. Alright, so I'm going to stop this video here, and then the last video, which will be video 3, we'll talk about rational exponents.